Hi, everybody, and welcome to this Q&A session for our Situ lecture series. This morning, we have the pleasure of speaking with George Lonsdale about his lecture on snake conservation in the cloud forest of Casuco National Park in Honduras. George is a MRes student at Cornwall College and Plymouth University, and he's also the lead herpetologist at Opwall's Honduras site in Casuco National Park. As a reminder, my name is Sophia Wood. I am the country manager for Opwall's Ecuador expedition, as well as the leader of the Friends of Wallacea initiative, where we're working with Opwall's partner communities around the world to develop sustainable tourism operations that enable them to conserve their land over the course of the year. Today, we have lots of questions for George about his work both in Casuco National Park and as well in science communication in the UK and around the world. So thank you so much for joining us this morning, George.
Yeah, well, good evening.
Evening.
Thank you. Your title sounds much more professional than mine does. That's quite the intro.
Well, it's really great to have you here. Obviously, your lecture was really exciting to see the kind of research that you are doing in Casuco, which is obviously one of our oldest and biggest research sites that we have. I think given kind of, totally forgot. Obviously, anybody, if you're watching this live, we're happy to receive your questions through the chat on Facebook or on YouTube, or you can email us at xsitu@opwall.com. You can send these throughout any time that we are talking on the Q&A today, and I will make sure to ask them to George so we can get your questions answered while he's on live. If you're watching this on the Opwall website, you can click the YouTube button so it will open the stream in a new tab, and then you can ask your question through the chat in there. And if you would like to be notified when we have new episodes of Situ out, you can sign up for our newsletter on the Situ page on the Opwall website. So sorry for missing that. So anybody who has any questions for George as we're chatting, and we got a whole bunch of them already, but obviously if you have any questions that come up, please feel free to send them to us and we'll make sure that they get asked. So George, I know a lot of the people watching this are kind of either wanting to go on Opwall expeditions or starting to think about doing a career in conservation. So I wanted to ask you kind of, what was your first volunteer experience? And how did you get started in conservation?
My first field experience was with university. I did my undergrad at the University of South Wales, and we had quite a heavy field-based undergraduate degree called International Wildlife Biology, and we spent a month in South Africa as our part of our first year, doing big game tracking as our module, which was amazing. Yeah. That was kind of like the first taste of field work, but the first kind of volunteering part of it came through Opwall. When I was in my third year of doing my, just between my second and third years doing my BSc, I got the opportunity to come out and do my undergraduate dissertation research, and got involved in Casuco with the venomous snake research from then.
That's awesome. So have you, basically, did you always know you wanted to work in conservation and specifically with snakes?
No, not at all. When I finished my A-levels, which is like the end of high school the equivalent for the end of high school in the States, I had no idea what I wanted to do. I knew I was like into being in the outdoors, and I knew I was like into climbing and things like that. So I thought maybe I'll go and do like outdoor education or something like this. But I found this BSc in the end, and I was like, oh my gosh, this course sounds amazing. I'll go and do that. And I was kind of convinced that I was going to be a marine biologist. Okay. I think mostly because I liked the idea of the lifestyle of lying on a beach, just kind of wearing board shorts all the time, being on a boat and diving, like all of that sounded really fun. But then when I got the opportunity to go out with Opwall in Casuco, it just totally flipped it on its head. And I think it was kind of like the exposure to being really involved in the science of it was like, oh, actually, this is what's cool. Like being in board shorts all the time is also cool and fun, but this is the more interesting kind of nitty gritty, like get your teeth stuck into it part of the work. And I really enjoyed that. So that's what kind of flipped me over to terrestrial research, and to get involved with the snake side of it. It was more about, I think, how little is known about snakes. Like a lot of people think they know a lot of stuff about snakes, but when you really dig into snake ecology, spatial ecology in particular, we really don't know that much. So it's a field that's been there for a very, very long time, but no one's really done that much studying on it, certainly not in any kind of depth. So anything that we find out is quite novel, quite new, and that makes it quite nice, because it feels like you're discovering new stuff as you're going through, even at like undergraduate level or master's level, like I'm doing.
Right. That makes a lot of sense. Well, so kind of that's a good segue into kind of asking you some specific questions about the research that you've been doing with snakes, and obviously a bit more about kind of what you were talking about in your talk. So one of the questions that came up was, you talked about chytrid fungus, and we obviously had John Colby on here several weeks ago talking about the impact of chytrid on the amphibian populations in Honduras. And so we got a question about kind of whether can chytrid fungus infect snakes, or is it just impacting them by killing off their food?
Yeah, and it can't directly impact them. The skin of reptiles and amphibians is totally different. They often get lumped together, but if you look like phylogenetically, they're very, very distant, very distant apart. Like hundreds of millions of years ago, they were split. So the funguses that affect amphibians can't necessarily affect reptiles. And when I know in my talk I said that it might affect them because it's killing off some of their food. What's important to note is that chytrid fungus affects amphibians by killing them, and there are maybe less amphibians around than there were before chytrid hit Kasuko. What we don't know is if it's affecting their kind of the overall biomass. Like then there might be less of those species, but maybe some species have done better because there are less of the tree frogs around. Like it's a bit more complicated than just there are no amphibians left, because there are. We still find them there. Also, we know now, because of the kind of natural history work that we've been doing, that these snakes don't just feed on amphibians. There was a paper that came out, I think it was 2016, that a colleague, Tom Brown, published of one of these palm vipers. It was an amazing photo of it dangling from a branch with this big mouse in its mouth. So we know that they do eat other stuff as well. So is it going to directly affect them by killing off all the amphibians? That would definitely have an effect, but we don't know how much of an effect it's going to have. Right,
that's fair. So obviously a lot of your research, or kind of the really exciting part of your research and the meat of it when you were getting into the end of your talk, is about the radio trackers and trying to figure out how these snakes move and what they do during the day over the course of months. So does attaching those trackers to the snakes impact them negatively or positively in any way? Does it make them less likely to be able to hunt by making them more noticeable to prey, for example?
The truth, we don't think so. When we attach the transmitters are tiny. They're about a centimeter long. They weigh less than 2 grams. And we have like a weight restriction. Like we don't put them on really small snakes. It can't weigh more than about 5% of their body weight, because then it potentially could have like a negative effect on its metabolism. So these bigger snakes, they don't notice an extra 1 point something grams. They carry on as normal. And the places where it could affect them is things like it's changing. For example, on a green snake, a big bit of silver duct tape might look different. It might make it a bit more obvious to predators. But the duct tape itself isn't really reflective. It doesn't shine in the sun or anything like that. It's quite a dull color on it. So it shouldn't affect them too much like that. And it doesn't actually restrict their movement at all. We made sure, especially on our palm vipers, they have a very prehensile tail. So we made sure that it wasn't on the tail, so they'd still be able to grip onto branches and things like that. So we were quite cautious in how we were attaching them. Other studies in the past have surgically implanted transmitters, but they're for kind of longer term projects where they're doing studies over several years. Obviously, the opal season only goes throughout summer. And if we let a snake go and then had to try and find it again next summer, it'd be very, very difficult. So the idea of having an externally attached transmitter meant that even if we couldn't retrieve the transmitter, when a snake next shed its skin, that transmitter would just fall off on its own. So it's only going to be, if it's affected, it's only going to be affected for that short period of time, and we minimize the effect as much as possible. That was kind of, we had to be really cautious in how we manage that. However, some of the snakes definitely noticed it was there to start with. We had one that immediately went under this log and just shed its skin. It was like, I'm having none of this at all. Get this off me. So that one just shed it off straight away. But then we had some of the palm vipers that it had no effect on them whatsoever. They were climbing trees. And we had some that stayed up in a tree for like 8 weeks and didn't move. But we think that was probably their natural behavior rather than the transmitter affecting that.
Yeah, I was going to ask you about that. Like, how does a snake survive if it doesn't move for 8 weeks?
Do you know, that is a question that I've been racking my brain for. So what's interesting about the palm vipers is we think we know what they eat. We think we know that they primarily eat tree frogs. And tree frogs are obviously up in the trees as well as around the rivers where we tend to see them most. So even though that snake wasn't moving at the top of that tree for 8 weeks, we don't know if it wasn't eating. We don't know if it wasn't drinking. There are bromeliads full of water up there. It rains a lot. Like, it can totally have still been drinking. It can totally have still been eating. It might just not have moved much from the kind of meter squared patch of branch that it was kind of resident on. The problem is that this snake is maybe like this kind of length, a bit less than a meter long. And it's green, so you can't actually see it up in the tree. So all you're hearing is just the beeps of the radio transmitter as you're kind of listening around. So all you're getting there is the location and the height of the tree. You can't actually, if you can't see it, you can't get any behavioral information.
Of course. So how do you go about getting these transmitters onto the snakes? Because also you're talking about several species of venomous snake in a very remote area. Have you ever been bitten?
Touch wood, not by a venomous species. I've been bitten by several species of snakes, I'm ashamed to admit, but not by anything.
Yeah,
it's kind of part of the job, unfortunately, but not by anything venomous enough to do any damage. So the answer to how do you put transmitters on is carefully. You use a variety of tools to handle the snakes. We never have like skin to scale contact if they're not in a snake tube, which is like a thin perspex tube. You put about 2/3 of their body into the tube, and then they can't turn around and bite your hand, and then you can quite safely kind of work with them, take measurements, take DNA samples as well. And then it also, because it leaves the tail sticking out of the tube, it means that you can attach the transmitters onto there. So yeah, it's all done really, really carefully. I've been working with venomous snakes now of all kind of shapes and sizes for like 6 years, something like that now, or getting on towards that. So I'd like to think I'm getting handy with them to be able to handle them safely anyway. And that's pretty much it. And then when you're actually attaching the transmitter, it's a combination of super glue and duct tape to attach it. It sounds a bit makeshift, but actually in the literature, it's pretty widely used.
Okay, that's fair. I mean, honestly, a lot of what ends up being done in the field is very scrappy, I think. Obviously, that's, a lot of what we do because that's what you have access to. You can't in the middle of a very rainy, wet forest, you can't necessarily use super high-tech gadgets because they'll die within 20 feet of your camp.
Yeah, for sure. I love it. Like when I compare like what I've done for my masters to some of my friends that work in labs, they're using like really high-tech equipment, and I'm like, yeah, duct tape and super glue. That's what I had. It's what I had in my pack, so that's what I could use.
Completely understand.
Yeah.
So you talked in your lecture about how you've noticed in Kasuko how niches are being squeezed up against each other, basically up the mountain through a combination potentially of climate change and habitat loss. Have you seen any species interactions like that are unusual, or kind of how do these species interact with each other now that they're crossing niches? Are the snakes territorial, or do they just kind of avoid each other?
So snakes aren't territorial, for one, but that doesn't mean that they don't interact with each other necessarily. They definitely will compete with each other. Okay. In Kasuko, we've got 5 species of pit viper, 3 of which are terrestrial, and they range in sizes from about 3 meters long, which is our Fer-de-Lance. We have our Mexican jumping pit vipers, which get to about 2 meters long, but they're a really fat-bodied snake, kind of like a big slug. They don't really move very much. Okay. You don't think. This is why we're radio tracking them.
Kind of an
and then we've also... Pardon?
Kind of an ironic name for a snake that doesn't move very much.
Yeah, a jumping viper, right? Yeah, yeah, got a very fast strike. That's probably where their name comes from. But yeah, they're kind of sluggish the rest of the time. And then we've also got our montane pit viper, which is quite a small snake. The average size that we find is probably like this, like maybe 40 centimeters long, something like that. But then max length, they're a little bit longer, up to about just under a meter, something like that. So they're all like relatively similar body length, and they all occupy a similar niche because they're all terrestrial vipers. So we can assume that they're feeding on things like small mammals, small amphibians, and other small reptiles. But obviously, if the Mexican jumping viper is living in the same place as the montane viper, then they're going to be eating the same things, and then they're going to be competing with each other. And obviously, they would want to, evolutionarily, they'll be trying to avoid that. And that's, we think, why they separate themselves out over the elevation range that we see, which is that the montane vipers are at the top of the mountain, the jumping vipers kind of sit in the middle, and the Fer-de-Lance, which are the really big ones, they kind of tend to be a little bit lower down, at least in Kasuko they do anyway. What we would expect is that if temperature increases, it would allow these larger bodied snakes to encroach on where the montane pit vipers tend to rule, because they're smaller, so they can warm up quicker, so they don't need as much temperature, they don't need it to be kind of as hot, which is why they can be a little bit further up the mountain. But it's difficult to observe in snakes because they tend to live for a long time, they move very slowly, and we're only there for a few months at a time. So we really need to look over our entire data set, which spans from like 2005 up to now, to be able to see these trends. You can't just see it in a 2-month snapshot.
Sure.
What we have observed, not in the snakes, but we've seen it in the birds of Kasuko. There was a paper that came out from some of our colleagues, Monty and Sam, who published about the birds encroaching on different territories. And birds are territorial, and you can see that there are birds that would normally be at the bottom of the mountain, they're coming up, and that they think, same as us, we think it's based on a combination of climate change and habitat use change as well. Right. Those are 2 things that are very difficult to tease apart. We kind of lump them together as like an anthropogenic effect, because it is really difficult to try and tease those effects apart.
Right, especially when you're seeing deforestation in so many different parts of the park.
Yeah.
And I presume a lot of that deforestation is in the lower altitudes as well, because it's easier to get to.
Yeah, for sure.
Yeah.
Yeah, the kind of the high mountain ridges, they tend to be the best protected, just because there's no point chopping trees down up there. It's really hard to get the wood out. So yeah, they
absolutely.
It's naturally a little bit better protected.
Of course. Have you noticed, or has Opwell found any niches or any species that have been kind of pushed all the way out to extinction since we've been working there?
In the snakes, no, we've not seen that. But we also might never see that. Snakes are by nature very hard to find anyway.
Right.
So it's really difficult to tell. There might have been species there, then we just never found them, and now they've gone. It's almost too difficult to say with snakes.
Yeah.
How do you prove something if you can't find it? It becomes quite difficult. And kind of this thermal ecology and spatial ecology of snakes, like I said, it's kind of a new field. It's not really been very well studied anywhere in the world. So this is what we're doing in asking these questions, is something that not very many people have asked before. So we don't have the answers to kind of use for reference for Kasuko yet.
Right. Don't have them yet.
Yet is the key word.
So I was going to ask you, so you obviously right now are studying an MRes. So what made you make the decision to kind of take this research that you've been doing with Opwall and turn it into a master's degree, and kind of what are your thoughts in the future?
The reason why is because we were doing this research, and we had Steve, my supervisor, was really interested in developing it, and the best way to develop it is to get an institution behind you to help you and to support you. So we were talking between Cornwall College and Plymouth, and we came up with this project and developed it from there. They already had an MRes kind of scheme that we got involved with, which was really good. And the thoughts for the future is a hard one. I'm kind of in the midst of writing up now. So we are hopefully looking to submit over the next few months. And then ideally some form of PhD, but that's long in the future yet. Not kind of been thought about too much yet, other than the idea in the back of my head. Yeah.
Right. Obviously the future is a bit uncertain right now, but as the people we've talked to who are doing research, I think you and many of them are lucky to have kind of completed the field portion and now are able to be working from home and writing up the rest of the research and able to get that done, even though this is not necessarily what we expected to be doing this time of year.
Yeah, for sure. I mean, it's obviously been very, very difficult. No one's got the motivation to be sat in front of a laptop typing away when everything's going on. But yeah, it makes it easy. It makes it a little bit easier, but not actually that much easier.
Yeah, I understand. Well, one of the things that was, I think, really interesting to a lot of the people who are watching is kind of your joint career between doing field research and then also working in science communication and interacting with a lot of people, especially about snakes, which are obviously a very understudied and very misunderstood group. I personally have an affinity for herpetology, so obviously feel for you in terms of trying to talk to people about snakes and convince them that snakes are actually good. So how do you both kind of become and then balance the two sides of your career between being a science communicator and then also being a wildlife biologist?
With great difficulty is how I'd probably say. And I mean that it can be really, really difficult. Basically, the way I do it is, so I got into wildlife biology through academia, and I will kind of progress through academia and progress in my wildlife biology career. My science communication kind of comes alongside of it. And rather than it being like a separate thing to balance, I'm kind of trying to feed it into my research as much as I can. I'm really keen on photography. I really enjoy, if anyone's on Instagram, I really enjoy taking photos of the things that I'm studying. So that tends to be like my main platform to do science communication through posts on that. But when I'm in the midst of doing research, I find it quite hard to be inspired and think about doing that as well. So sometimes I'm more research focused, and sometimes I kind of let that drop off, and then I'm more SciComm focused through social media. But the best thing for me to get involved in science communication was all about networking. And the more people that I networked with, and I told them that I was really interested in photography and really interested in science communication, the more opportunities that came up and came out of it. Probably some of it was down to luck, like meeting the right kind of people and getting involved with them and kind of making sure that they remembered my name and stuff like that. And that led to things like talks. I got this really cool gig working and doing talks on cruise ships, telling people about snakes on cruise ships, which, I mean, it's pretty bonkers when you think about it, but people enjoyed listening to these talks. So
where do those cruises go?
I've done a couple. I did one around Central America, which was really nice.
Awesome.
Yeah, and then one around like Western Europe, like Portugal and the Azores, which was really cool as well. And I was just doing talks about snakes and wildlife biology, a little bit about like biogeography. But taking those concepts and making them digestible for the average person who's on a cruise ship, which probably isn't a wildlife biologist.
Yes, absolutely. Well, you're not the first person to say that networking is really important, but I think it's something definitely to highlight kind of as we're going through this, because I think networking comes to light a lot in a lot of other fields, but certainly I think biology, and especially when you're more on the research track, people don't talk as much about how important networking is. But to get the visibility that you're kind of doing right now, I think obviously just talking to people all the time is a really big part of it.
Yeah, and I think especially, especially going to conferences and things, even as like an undergrad, I was going to as many conferences as I could. I was going to one specifically about snakes, but there's conferences all over the world that have like grants that allow people to go to them. In the UK, getting grant money is a little bit difficult, but it can be done. And there is like a bit of support out there to get yourself to a conference. And then networking then becomes a little bit more easy because everybody that you're interested in talking to is all in one place. It's kind of like a hyper concentrated like network opportunity. You've just got to go around and talk to everybody.
Definitely. Well, obviously we're a while off from conferences but that being said, I've heard that there's a lot of success in cold emailing right now because everyone's just sitting in front of their computer wondering what to do, and it's the equivalent of networking at a conference. Just, unfortunately we can't all be together. So we have about 5 minutes to go. So for anybody who's watching this live, if you have any final questions for George, please feel free to put them through the chat on Facebook or YouTube, or you can still email them to us at xsitu@opwall.com. We'll make sure to ask George before it's out. And obviously, if you send them in afterward, we'll make sure these questions get to him so you can get an answer. So just as we're wrapping up here, I want to ask you kind of how do you have, besides the networking, which we've obviously talked about, kind of for someone who's interested in maybe going into science communication, are there any opportunities that people should really look out for or take part in to kind of get their name out there or start working in science communication?
That's a really hard one for me because, like I said, like my science communication might be different to how other people do it because I do it kind of alongside my own research. There is definitely really good ways to do it. Many universities around the UK do courses on science communication. I think you can get a master's degree in science communication now. And then there's other courses in like wildlife filmmaking, which again, if it's the way of tying it in to science communication. So if you make a film and then give the information in the film and make it digestible for everyone, that's your link to science communication. But in all honesty, I think social media is the best platform that you can use. And building a bit of a following on that and kind of spamming people a little bit to make sure that your name is getting out, that your platform is getting out there, and then people will see it, is the best way to do it. Like I said, it's different for everyone. And the most important thing is that whatever you're communicating, you're making it digestible and as easy to understand for everybody, not just your science community.
Right. I think that's a really good point. And I was hoping you would bring up the social media aspect because I think obviously it doesn't always have to be, you might not be a photographer, it might not be Instagram. It might well be a blog or it might be video, whatever's your medium. But I think you made a really good point in terms of just like starting with what you're good at or what you're passionate about and doing it consistently in a way that you're sharing it online so that people are starting to see, because you're absolutely right that everything now, especially in terms of communication, is digital more than ever today, obviously. So it all starts with, that consistent work.
Yeah, for sure. And like there are so many good examples that you could look at online, like so many good, I use Instagram mostly, so many good Instagram platforms that people use. Mine is certainly not the best, like people do way better than I do. YouTube is a really good tool for absolutely everybody. And like you say, blogs, Twitter, the Twitter science community is enormous. So get involved with that. People love it. Absolutely.
Well, this has been fantastic. You've talked a bit about your social media, and obviously you have quite a presence. So I want to give you a chance to shout out any websites or social media that people should follow to keep in touch with you or the work that you're doing.
Okay. My Instagram is @George Lonsdale. My website is georgelonsdale.com. And you can, easy. And feel free to like email me through that or comment on photos or anything, like DM me or anything like that if you have any other questions that we haven't had a chance to squeeze into this half hour. Just fire them over on that and I will try and answer them.
All right, well, fantastic. Thank you so much for your time today, George. It was great to learn more about your research and your work in science communication. For anybody who is tuning in or who's turning in after, thank you so much for joining us. And if you have any further questions for George, you can find him on Instagram at George Lonsdale or through his website, georgelonsdale.com, or you can send us any questions for him through xc2@opwell.com, and we'll make sure that they get through to him. Thank you so much and have a great rest of your day.